Hey guys, I want to go ahead and talk about finding compound interest. Okay, and essentially what you're going to do, guys, is basically use a formula, plug it in. We're going to go ahead and take it step by step and just to kind of make sure you understand all these variables here. All right, so the first example says find the amount of $5,000 deposited into an account at this interest rate compounded quarterly for 10 years. So when you're starting to do these, it's very important, guys, that you start and label them out. Okay, so A is your amount. Okay, P is your principal, the money that you start with, and then R, that's your rate. It's usually in percent. And remember, the percentage, you have to change it into a decimal, so you have to change it by moving it twice, 2 spaces to the left. Your N is the number of times it is compounded. Okay, and your T is your time in years. All right, so it says find the amount of $5,000 deposited. So $5,000, that's what we start with. Your rate is 4.25, they give it to us, and quarterly. Okay, how many quarters in a dollar? Well, there's 4, so you're going to use N equals 4, and then 10 years. And then all you got to really do is input your values here. 5,000, 0.0425 divided by 4 to the power of NT. Now be careful, okay, you have to do this fraction first, but if you put it in the calculator, you should put 1 plus, and then this fraction is separate. Okay, and basically, guys, you put it in the calculator and you should get this value. All right, let's take a look at the second example. All right, it said, let's say you have you deposit $6,500 into an account that pays 8% compounded monthly. Okay, so this one's a little bit different, but it says monthly. How much money will you have after 7 years? So if you notice, we're doing the same thing. Deposit $6,500. So that's what you start with. That's your principal. Your rate is 8%. Remember, change it into a decimal. Your N, the number of times it's compounded, is 12. Well, why 12? Because it's monthly. There's 12 months in a year. And then T is 7 years. So this was pretty easy. This is like a level 1 question. And then you just plug it in again, and you should get $11,358. All right, guys. Let's take a look at number 3. They get a little bit more complex as we go along. It says, how much money would you need? Now look at it carefully. How much money would you need to deposit today at 9% annual interest compounded monthly? Okay, compounded monthly, to have $12,000 in 6 years. And that's what we want to find out. How much do I need to deposit? How much do I got to start with? Okay, we don't know. We know the percentage is 9%, becomes 0.09. We know it's compounded monthly. Okay, that means N equals 12. We know it's 6 years. All right, and then we want to have $12,000 by the time everything's done. Okay, so again, then we just go ahead here, start with our formula, and there's just no other way around it, guys. You're gonna have to memorize the formula. We want 12,000. We're trying to find the P. Notice here we're gonna have to do this value here, same thing. Now what you're trying to do is find this guy. So what I did is you could divide everything by this whole value here. Okay, and essentially you're gonna have to use a calculator. So if you have a good scientific calculator, go ahead and just put this 12,000 over this value here. If you don't, just go ahead and piece by piece do this first, and then raise to the 72nd power, and then you divide it, and you should get this amount. All right, and remember, we're looking for P, not for the amount. Okay, let's take a look at another example here. Let's say you deposit $5,000 into an account paying 6% annual interest. It's compounded monthly. Okay, it's compounded monthly. How long until there is $8,000 in the account? So I start again with my values. My P, my principal, is 5,000. My rate is 6%. Okay, 0.06. It's compounded monthly, so N equals 12. How long? Well, I don't know how long. That's what I'm trying to find out. And then until there's 8,000 in the account. All right, so if you notice here, I start off with my formula. I want to have 8,000. 5,000 is my principal. I input all this, 12t. Okay, so you want to solve for t, and that's the difference in this one. Okay, so what do? I did this first here. Put in my calculator, I got 1.005. And then you're going to divide by 5,000. Okay, we want to solve for t, so divide by 5,000. You end up with 1.6. Now this becomes an interesting problem here because I need to get this t to the bottom. How do I do that? Well, you're going to use logarithms. Okay, you're going to use log. So you're going to take the log on both sides. And when that happens, you can use the power property of logs. Bring this guy to the front. Okay, so 12t multiplies the log. And then just use your algebra. Divide by log of 1.05. And notice I also divided by 12. So these guys simplify out. This guy simplifies out. Okay, these two here. And then you're left with this value. Put in a calculator, you end up with 7.9 years. All right? Sorry. You end up with dividing, calculator, and you end up with 7.9 years. All right, guys? Let's go ahead and do another one. If you deposit $8,000 into an account paying 7.25% annual interest compounded quarterly, okay? How long until there's $12,400 in the account? So for this one, same thing. We start off with our values. That's the best way to do it. That way you don't get confused. But your A is $12,400. Okay. Your principal is $8,000. Your R is your percentage. And so 7.25. Now this is going to get long, but it's okay. Your N, number of times it's quarterly, so it's N equals 4. And you're trying to find how long. Okay, how long. All right. So same thing again here. Your amount is 12,400. Okay, because you deposit 8,000. How long till there's 12,400 into the account? And then we plug in our rate divided by 4. Now from here, what do? Okay, we're gonna go ahead and same thing, divide. And we're gonna divide by 8,000. 8,000. Okay. And then over here, when you do the math here, you should end up with 1.018, I believe it's 125 to the 4t. And then we're going to divide 12,400 divided by 8,000. Okay. And what does that come out to? And that comes out to 1.55. Okay, so now what do? Well, I got to bring this guy down. So what do? I'm going to take the log. Okay, so I'm going to take the log on both sides. Log. Now, does it matter if I do log, log, or ln? It doesn't matter. The only time you need to use ln absolutely is when you have a base of e. But other than that, ln or log works fine here. So now, what do? I can use my power property. This guy's going to come out to the front. All right. And so we have log 1.55. So it's 4t times log of 1.018125. I believe that's right. And then we want to solve for t. So now you're going to divide by 4 times the log of 1.018125. And if I'm off by a little bit, I'm sorry, but I think you guys understand the gist. And then 4 log and 1.01825. All right, so what happens? These guys simplify out, these guys simplify out. We're left with t is equal to approximately 6.09 years. All right, guys? So this is a little bit different because when we're calculating for the time, you have to use logarithms in order to bring it down. Let's go ahead and do one more. Okay. We'll do one more. Now this one, I like this question. It seems a little bit tricky, but it really isn't. It says at 3% annual interest compounded monthly, how long will it take take you to double your money? So you want to double your money. So we start off with our values, same thing. They don't give us the amount, how much we're going to end up with. They don't give us how much we're starting with. They give us a percentage. They give us its compounded monthly. And this is what we're trying to find out. Well, then how are we going to solve it? Well, if you think about it, we're starting off with our formula, right? Well, whatever money you have, that's going to be doubled. So that means you're going to have 2p. Well, all I got to do is some algebra. Well, first I did this part here. 1 plus 0.03 divided by 12 gives me 1.0025. What do you do here? Well, all you got to do, guys, is essentially you're dividing by p. And this guy simplifies out. So you're just left with a number of 2. So the initial value really doesn't matter. Now you're left with this. Well, what do you do now? Well, you're going to take the log. Okay, so you're going to do log on both sides. Log. So log of 2. And then log of 1.0025 to the 12t. Okay, and now power property, you can bring it down. And you have 12t times log of 1.0025. Same thing on the left, log of 2. Okay, and then you just keep going. We're going to go ahead and divide by 12 times log of 1.0025. Same thing on the left, 12 times log of 1.0025. All right, and do your math. Okay, so the 12s are going to simplify out, the logs are going to simplify out, and what do you end up with? You end up with approximately 23.1 years. So in about 23 years, your money will double, whatever it is you initially deposit. Yeah, it does sound like a long time. But hopefully that helps, guys, and we'll continue next time.